Yeah.
Perfect. I'm Carl. My nickname is Ice, and I am team responsible for the network crew. Maybe if I stand here. This presentation will be in 3 parts, and the first part will be by me, team leader for network. The next part will be from Toast, which will talk about behind the scenes the construction of the whole of Dreamhack. The network team that I represent is about 30 people. The whole of Dreamhack crew is 450 people. So here we'll get some interesting facts from Toast. And then in the end, we'll do a really technical talk from Robin, who is part of the network team. He's in the service part. I'll get back to that later. So for me, I am Carl Anderson. My nickname is Ice. I'm team leader together with Robin. Robin is down in the D hall, and I work at NetAdmin Systems, which is a software company in Linköping with about 50 employees. And now I'm here on building Dreamhack, and I've been doing that for about I don't know, since 2002. The summer event was the first time I was in Dreamhack crew. Excuse me, can I get some water here on stage? Why do I do it? I love technology. It's fun. It's extremely. It's like climbing Mount Everest, I would guess. I have never climbed Mount Everest, so I wouldn't know. But that challenge does, for us, it triggers something in everyone that is building Dreamhack in the crew. That and my extreme interest for everything with technology, everything from computers to network and so on. So, the team. This is a picture of the team in the area where we work, and we sit at, if you go left from the escalator that goes into the D hall from the B. Let me turn this off before it goes. There we go. So that's where we are, and if you have some interesting question, don't hesitate to knock and come by and say hello. We might not have time to you, we might be rude to you, but that is usually because we have a lot of things to do, and if there is any problems, then we might be rude. Please excuse us. That is just that we have a lot of things to do. But if you ask nicely, you can definitely come and get some interesting answers. Yeah, we are 30 persons. We have 4 groups in the network team. The first one is Access, which uses all the table switches, everything that is on the tables, and uses the TP from the table and up to the core network. That brings out the next team, or group, which is the core. And they handle these big ASR routers and the Cisco routers and wireless and so on and so on. Then we have Services, which is handling servers like DNS, DHCP, every add-on service that we need to build the network. And we have a lot of internally developed support system that is used to help our work and make it efficient when we build this. We also have a fairly new group for, I think, 2 events now, or maybe 3 events, which is logistics, tech logistics. This is a small team with 2 persons in, a small group with 2 persons, and that is used to handle about 40 of these the ballots that we put all our stuff on, because there's a lot of stuff, way too much stuff if you ask me. So building the network for Dreamhack is quite challenging. We start with doing the planning for it about 3 months, or actually for this event we started at the last event. This was for the 100 gigabit link that we have now. So that started last event, and then we start about 2-3 months before the event with having meetings on IRC, and we have bi-weekly meetings on IRC where we talk and see what should we do, what do we need, what requests have we gotten, and so on and so on. And then we go into the event where we start building, and that we build for 5 days, and we build for about 14 to 16 hours per day with hopefully 6 hours of good sleep every day. Usually not more, unfortunately. So it takes about 3,000 man-hours to build the network at Dreamhack, and that's just the Dreamhack network team. About that, we take in resources from the building and tearing down team, which assist us with putting on table switches and whatever. So it's quite a big project, if you ask me. Let's see. Yeah, then we operate the network for 72 hours while the event is up and running, or actually it's a little bit more than 72 hours because the sponsors are a bit earlier than the rest of the participants. And there we have 24 hours a day NOC, or Network Operations Center, where there is one person from these three groups, everything except logistics, which is on site, and if anything happens, they are ready to go out, replace a table switch, or change a configuration line on the routers. Handle troubles. Aside from that, we have a support team at Dreamhack, which assists us with a lot of things. They handle the first contact with our participants. They are actually first-line support and second-line, and then we are third-line support when things are broken further up in the chain. And this support team handles the electricity, and they handle things that are wrong on the computer or the cable to the switch. When it's all done, we tear down the network in about 1 day. And this starts it starts tomorrow at about 10 o'clock. Then we start tearing down the things that are closed and not used anymore, like the expo, which is closed at 10 tomorrow evening. And then we start in the morning about 7 a.m., and then we tear down all the way to the evening when we are hopefully done, which we usually are. Some internet history at Dreamhack. We started with 1994. There was a modem connection, quite slow, I imagine. I wasn't there. Then we had 2 times 10 megabits per second. We got 34, we got 1 gig, and then about when I started, when I was at Dreamhack the first time in 2002, it was about 1 gig, and then it goes up and up and up, and then 2007 we got 40 gig to Stockholm, and this is similar to what we got now, and we got 110 backup. And for this year we have 120 gigabits per second, and that is 100 gig and 2 10 gigabits. So the 10 gigabits goes from here to Jönköping, and then the 100 goes to Stockholm, so that's quite far. Internet. If you have visited the Tech Pop down in Hall D, you have seen this visualization, which is built by AG Consult, Anders Gren, or Anders Gren, who built this, and this shows a lot of things. Now I'm going to do something that I usually don't want to do, but let's try. Let's do a live demo. Let's see if it works. Seems to actually be working. There we go. It's even spinning. On the top left, you can see a rotating globe, and that is where Dreamhack connects in the world. As you can see, if it's a bright white, then there is a lot of connections to that place. If it's a little bit less, then it's less. So if you look at this, you can see it's basically all around the world. You can go over here, we'll see. Yeah, someone is connecting here. I have no idea where there is, but they are connecting there. You can see some client count, how many, this 345 is basically how many 1 terabyte hard disk that has been downloaded into Dreamhack, or actually sent out, and then 459 is how many has been sent to Dreamhack. We have some speed, some graph, and the bottom right is actually working perfectly. Some people think that it's not, but it is. It's a stacked graph over how many percent games. So you can see that World of Warcraft is taking 3/5 of the players. So that's quite interesting statistics. And we're quite close to beating the world record in amount of clients. So you'll have to connect your phones and everything to the network so we get some more MAC addresses. Let's see. There we maybe go. Yeah, this is why I don't want to do it live. Let's see. There we go. I really have to go a course in PowerPoint or something. TechPop. This is a newly created concept for this event, and that is where you have the big sign in the D hall where it says 120 gigabits per second, and then there are 3 big racks with a lot of equipment in it. And to supply all this, or actually this is the core routers of Dreamhack. All the traffic, if you go from one switch to another on a table, the traffic goes through these routers. And to power this thing, it requires 2 times 63 ampere. This is the big cables of power you can see all around. And then there are 2 gray cables going into the cabinet. So there are 2 of those. There are 24 pair of fibers and a lot of twisted pair cable coming in there. So if you have any questions or ideas, just come down there, and we'll be happy to answer any questions that you might have. I'm actually just going to go a quick check and see what time it was tomorrow, because we're going to do a tour, and this is a new thing, and this is going to be tomorrow. So at 12 o'clock tomorrow, we're going to try something new. We're going to do a guided tour for everyone who's interested. So at 12 o'clock, someone from Dreamhack Network will be down at the pulp, and just come there, be there, and we'll start the tour at about 12 o'clock. So be there before 12 o'clock, and we'll come at 12 o'clock. Please come and visit. These are some photos of the pulp. On the left, you can see the routers, which is a really nice picture. It's taken by Helena. And on the right, it's me who is doing something. I'm not sure what I'm doing, but something. So, equipment. To build Dreamhack, we use about 450 table switches, and these are the top 3 switches that you can see in this picture. They are about 24 to 48 ports, and you can see them everywhere. They are on every table, 3 on every table, 2 on some tables. Then we have the Cisco ASR 9006, which is on the sorry, you're quite correct. It's ASR 9010. I have no idea where they got that slide from. And that are 2 of those. They are on the left and on the right side of the 3 racks, and they are used to route all the internal traffic, and then they send it on to the CRS, which is the one in the middle, which uses the 100 gig uplink. So they send over the traffic, and then CRS sends it over to Stockholm, and there in Stockholm it's spread to the whole world. We have about 30 Cisco switches in the network to distribute the network, for example, to this place. I'm not seeing any APs. Well, if you turn around, you can see little 2 blue dots. They are APs, wireless access points, and they are connected to ports here somewhere, and they are connected to the Cisco distribution switches. And these are placed by us during these 5 days. So we build a temporary infrastructure above the existing infrastructures, like TPs here, and we do a lot of temporary cabling as well. We run about 25 physical servers down in the tech pop, and this is some blades with a lot of servers, so that's why there are so many. And we use about 20 virtual machines for different kind of things. 35 VoIP. We have a VoIP so that the different teams, for example, the stores in the D hall can call the stores in the B hall and say, "Hey, I'm out of Coke. Can you get some cola, please?" And we have 90 wireless APs. So the ASR 9000. It's previously we used the 7600, which is a platform from Cisco that run iOS, and now we use this ASR 9000, which is a much faster version, or it's a completely new platform compared to 7600. So it uses iOS XR, which is not a shared memory architect, so it's very much more stable. It's faster. It has much better protection against attacks and overloading things. Sometimes at Dreamhack we have had some problems with maybe a broken switch or something sending a lot of traffic, and that has caused some problems. So this one is doing very, very much better, and it's much more stable. We have the Cisco CRS 3, which is Cisco's fastest router that is used in carrier, building big ISP networks, from example Telia, which is our internet provider. We use the 4-slot model, which is the smallest of the Cisco CRS 3s. And in this one, there is on the right side, there is a line card, which has like this thick blue cable, and that is 100 gigabits going through there. And this one goes up to the ONS, and the ONS is used to go far distances or long distances with light. So this machine makes the cable the 100 gig going in there, and then it changes the light, so the light becomes suitable for transmitting it in a DVDM system. And then in this one, we're using one wavelength that goes all the way to Stockholm. And on the way, there is a lot of repeaters, which makes the signal stronger. So basically, it changes the light, or it remodulates the light, and sends it off to Stockholm, which is a very long distance. So this is cool stuff. And this is a picture showing how it looks. You can see on the left, we have our aggregation switches, which is two 3750 stacks that is connected to both of the ASR. And then these are connected to the CRS, and then the 100 gig, the ONS, and then all the way to Stockholm, and then the same, but in the opposite direction. And then we go out to the internet. You can also see on the top and the bottom, we have our two 10 gigabits backup links, which goes to a router in Jönköping. Yes. Can we take questions now? Yes, so let's take, wow. Yeah, okay, skip the question. We'll take the question at the end. So this is an overview of the whole network, or actually the whole Elmia. We have on the right, we have the Hall D. On the middle, we have the top, we have Hall B. And then on the bottom, we have the Hall C. And we use in the POP, you see the three big, that's all the roads lead to, that's the tech POP. And then there is a star network going out to all of the distribution switches. What is not shown in this picture is all of the table switches. They are actually connected to each and every one of these, where you can see two, there is, for example, the center stack. There is the table switches going in. Some bandwidth usage graphs, some connections per second statistics, some top subnets, how much traffic is being used, showing some packet loss, and packet loss is not always a bad thing for TCP, because TCP works that way. If you send a lot of traffic, TCP uses packet loss to throttle back. When you, for example, send from here at Elmia or here at Dreamhack, you have a 100 megabits per second connection, but the place you visit or sending traffic to, that might just have much less, maybe it has 10. So what TCP uses is packet loss, so this is a way of measuring the quality of the network, and this is something that we use packet logic from Procera to retrieve these kind of statistics. We use IPv6, and IPv6 is the next IPv packet or internet protocol, which is using longer addresses, because they realized that, oh, we're running out of IPv4 addresses because these are like this small, and IPv6 is like huge. So they put in a lot of more bits, and they're trying to convince everyone to start using it because we are out of IPv4 addresses. Luckily at Dreamhack, we got our scope, which is, we got our allocation for IP addresses like a few years ago, so we got a bunch that we're going to be okay. But I think it's getting very hard, and we are out of IPv. So please use IPv6. Go to google.com, how do I use IPv6, and start using IPv6. And YouTube, because YouTube uses IPv6. And if you have problems using IPv6, please go to visit our support team, which you can see in Hall D in the bottom or in the south part, and there says support. Go there, say, I have a problem with my IPv6, please help me, and they will help you. Some bandwidth on IPv6 is not being used that much, but please use it more. Some fun facts. We use a lot of cabling here. About 25 kilometers of cable is put down by us, like put one cable, and to manage to do this enormous amount of cabling, we use core stab. I have not learned the English word for that. We use a bundle of cables that we put into long. And if you look up, for example, in Hall C, you can see they are yellow and they go up in above the tables. And they are connected to table bundles that goes out on the table. So that way we go quickly on all the tables, putting out the table bundles, and then we hook them up with the things that go out into the distribution switches. some incident. The most common incidents we got or have is broken table switches. They are, for some reason, broken. They were stored, there was a cold or something broken with them. Some broken TP cables. We had one incident before or during the building where one thing that you use to lift things, forklift, thank you, where one forklift hit one of these going over, and it was, so we had to fix that and repair it. Luckily, that usually don't happen during the events because there are a lot less forklifts. We had some issues with multicast yesterday, which caused a lot of issues in the network, which we have hopefully resolved now, and there should be no further issues there. So these are the kind of things that we work with during the events when participants are here. Configuration of table switches. Last year I promised that we would do it faster, and we did. Because last year we did it in 50 minutes, all of the switches, and this is what we have here is an in-house developed software that the network team has developed that is going out to each of the switches and configure it using an ARP hack. So it's going in, it sends one ping packet, it gets a lot of ARP replies, and then it shows one of them, put it into in the ARP, or put in a static ARP, configures that one, and goes on to the next switch. And we have about 450 switches, and we did it in 50 minutes last year. And this year, we wanted to do it faster, and we did it in about 4 or 5 minutes this time. So it's about a 10 times increase. It's convenient to be able to do it faster. Would it be convenient to do it in 30 seconds? No, not really. Could we do it? Probably. We do a lot of testing before participants arrive, so we go through all the table switches, test. And we use VeriMi, which is an in-house developed also software that goes in, searches where you are when you're connected, and sees, yeah, you are on this switch, then we know you're on the correct switch, and we can use it for troubleshooting when we do the monitoring of the network, which we use as an NPC to do. And there is a lot of green dots, that's good, a lot of red dots, not so good. So when we got a problem here, we'll go out and fix it. And this is support helps us with this also. And when you get an electrical cut on a table for some reason, it will be a red dot, support goes there, fixes it, and the people that experience the power have usually not yet arrived at the support booth when this happens. Yes. At dreamhack.net.se, there is a portal which we put in last year, which you can use to see your own port statistics. And if you go to that site, you will see the port statistics, how much bandwidth did you use, and you can share this link or this graph for yourself on Facebook, for example. So go visit dreamhack.net.se and see how much you're using. So we have a lot of partners that we're working together with. These are some of them. Telia, providing internet. Tekniska Högskolan helps us with providing some tables, and we have an area where we prepare at Högskolan. Cisco is one of our biggest, or is our biggest partner in the network side, where they deliver a lot of heavy machines to do all the routing and provide a really fast internet. Wireless, there is a wireless network. We use about 90 access points, which is spread through the whole area. And as you can see, there are some blue dots, and they are like these big white, and they are thin, so we do not configure them manually, but we hook them up, plug them in, and then they connect back through the network to a wireless controller, which is located down in the tech pod, and this one then configures them and puts out the correct SSIDs and so on. Dreamhack Crew is recruiting, so if you are interested in doing work for Dreamhack, building Dreamhack, please come talk to me regarding network or developers. If you are more interested in general Dreamhack Crew, visit crew.dreamhack.se and you will see all the information that you need. So, a few minutes left for questions. Let's go for questions. Hand raised if you have any questions.
Hi. When I was down looking at your rack cabinets down in Hall D, I couldn't help noticing you've got a PXE server. Could you explain to me which device is PXE boot?
If I heard it correct, was it what the PXE, what PXE does? Yes, okay. So the question is, what does the PXE server do in our rack? PXE is a protocol that is used to load operating systems onto machines. So basically, if I have my laptop, when it boots up, it will say Intel PXE, maybe if I have an Intel card. And what this does is that it tries to connect to the network, send a DHCP request, and from the DHCP, it gets a client back, and it gets a TFTP server. And on this TFTP server, it downloads an image, which is a software package. So the laptop or the server, which we use them, is to install servers. So we hook the machine up, we activate it, and connect it to our PXE network, and then it's loaded with Ubuntu or whatever we run, and then we install it. Did that answer your question?
Yeah, just to clarify, so it's your servers that PXE boot, all of them?
Yes, we use them internally to be fast on installing servers.
Okay, thanks for the answer.
Does NetAdmin have any open source software that you could use at home for trying out?
We have actually at NetAdmin we use a lot of open source, and all the software that we have used is available from our homepage. So if you visit www.netadminsystems.com, you can see the software that we have there.
Okay, thanks.
Hi. Are there any? I saw a lot of graphs really quickly, and I saw that people were not downloading while they sleep. Are there any other things that amaze you as a tech guy about network usage? Is there something special?
I'm not sure I understand the question. Let me rephrase it and see. The question, or was the question that are there any other services that is used for a lot of bandwidth, or?
No, are there things that you would not expect, like for example, people are not downloading while they sleep, and or people are downloading a lot of things while they sleep, or there are peaks in streaming usage, or peaks in other things that you came across, or it's just plain simple network?
Well, if you look at this, we can see there is a little dip during the night. It's not huge, so yes, there is less bandwidth being used during the night. And we can also see on the gaming statistics that we use that there is a lot of less gaming in the night. Gaming goes down during the night. So the perfect time for a service window for us is actually not like 3, 4, but actually like 6, 7. Because the people play, and then at 6 they kind of stop. So 6, 7, 8 there. Then is when the least people play or use the.
Okay, thanks. And about network security, you haven't spoken about that. Is there anything regarding network security, or I saw IPv6 and the need to use it. What about people that use the latest tools for hacking on the network? How do you detect them?
That's a very good question. Let me bring up a picture. Maybe not that one. What we use to protect our infrastructure is we use a firewall from FortiGate. No, we use a FortiGate firewall from Fortinet, which is a firewall. And this firewall helps us protect our service, and it helps us protect our infrastructure with the routers so that people can't attack them. And we use IPS, which is looking at the packet and see if is anything looking like intrusion attempts, and then we stop those to protect our infrastructure. Regarding the participants, we don't do anything. That's they have to use their own firewalls, their own antivirus software, and everything like that. If they have problems, the support team will help them, and if they are expected or attempts to hack them or anything like that, attacks or signs to that, and then the network team usually assists in forensic work if there is things like that.
Yeah, so there are people looking at what's going on.
Exactly.
All right, thanks.
So we aren't using a whole
make
lot
a
of that
capture.
100 gigabits per second. Would we actually survive on the backup links?
Could you repeat the question?
We aren't using a whole lot of that 100 gigabits. We're only using 15 and 13.
Yeah, you're not using that much bandwidth. Why
So we
aren't you?
should survive on the backup links?
At this rate, yes. Yesterday at 23.4 gigabits, no.
Kinda
But today
disappointing.
we can survive at it. And what happens if we actually get a cut on the, like someone digging on the 100 fiber, which is sometimes that happens. What will happen then is that we fail, we fail over to the 2 times 10 gigabit links. And if the traffic is larger, we use the packet logic, which prioritizes game traffic. And then that way, when we go down from, well, 23 or 24 or 5, what we'll do that is that the non-prioritized traffic, like not gaming, will be pushed down faster than the gaming traffic. So even if we have a smaller pipe than we need, we can still survive with the gaming and the gaming getting more priority. And that is all gaming.
How do you classify packets?
This is the
Constant
packet
or-
logic. I don't have technical details exactly how it does that, but it uses ports and so on. Yes, the packet logic is a deep packet inspector. So it uses application layer to see what kind of traffic, and it looks at the session initiations to see, okay, so this is gaming, then it put it all that flow into the gaming class, and then that is more prioritized than bulk file sharing, for example.
So the 100 gigabit connection is full duplex?
The 100 gigabits per second is symmetrical and full duplex. So you can go 100 up and 100 down.
What do you think contributes to so much egress traffic on the network? I mean, it seems like it's so much above ingress.
What tribute? I'm not sure. We are not collecting that kind of. We're not looking at that kind of information, but generally, gaming uses little. Downloading from FTP or something uses a lot of bandwidth.
Are there any plans to bring gigabit switches to the tables?
Sorry, could you repeat the question?
Are there any plans to bring gigabit switches to the tables instead of the 100 megabit switches?
Was the question that are there any 1 gigabit per second ports to the participants?
Yes. Are there any plans to?
Yeah, okay. Yeah. So the question was, are there any plans to put 1 gigabit per second to the participants? Now there is 100 megabits per second. And the answer is we have on the VIP row for Telia, there is all those ones get 1 gigabit per second access. And in the future, we'll see.
Thanks.
One more question. How do you guys control rogue DHCP servers on the table switches?
For rogue DHCP, we limit them to it's one switch, or actually it's one table, because the broadcast is only on one table. For the sponsor part up here, we limit that by using protection in the access switches. So up in the expo part, you couldn't do it, but down on the table switches, some of them, we don't have the protection abilities, but it's limited because we use a lot of routing. So if there is a problem with the rogue DHCP, we'll see it quickly. The people will say, it's not working, and we go there and we can fix it physically.
Are there any?
I think we'll go for the next question now. So
Okay, thank you.
you will have to raise your arm later.
Could you tell us a bit more about the multicast problem we had yesterday?
Unfortunately not, because I haven't been in touch with the technical and gotten a sync yet. We haven't gotten time to that.
How do you measure how many unique pieces of equipment are connected to the network? Because if it's just unique MAC address, I can just generate as many as I wanted and put the number to, what, I don't know, 1 million or so.
I could not hear that question. Can you repeat it and use it shorter?
Yeah. How do you count the number of connected equipment to the network?
That is using two techniques. The first one is looking at the DHCP, which how many MAC addresses do we got in the DHCP lease file. And the second one is looking at the packet logic, collecting that kind of statistics.
So if I generate a lot of MAC addresses on my computer, I get the counter up.
You could add that, but then we'll see that and stop you from doing it, because that would interrupt with our network.
Okay, so what is the limit?
I didn't hear that question. So. Oh, no further question? Then thank you for coming, and I will hand over to the next speaker.
Thank you.
My name is Toast, or my nickname is Toast. My real name is Tostestava, and I've been called Toast since the beginning of time. And I'm here to talk about a bit more the soft parts of Dreamhack, and what building is like, and what we in crew do, and what it means to be crew here, and what perks there are, and why more people should come join crew, because the core of crew is we're getting old. We're getting above 30 like the base group, and we need more people. We need new people that are interested and willing to put effort in. Since Dreamhack is growing as well, we need more people to fill the seats that needs to be filled. So I'm going to talk about behind the orange shirt. I named this part of the presentation. So I'm going to start to talk about a bit how Dreamhack is built, just very shortly, and how it's physically, how we manage to get everything done in time, what we in crew do, what do we, what kind of roles do we have, and how do we perform them, and then what it means to be crew. What do we get out of it? Why are 450 people here not paid, working for over a week, and getting to sleep on a stone floor, and getting like school lunches. So I'm going to start to talk about the normal picture of Dreamhack, and this is what you usually see or imagine when you hear Dreamhack. It's like a big, huge, dark hall with lots of computers and maybe a bright stage where something is happening. But before you get there, there's is it echoing? There's this step, and this is just before everyone enters. Here the event is basically built already, but this stage is basically just a few hours before we open the doors. So it takes a lot of time, and there usually maybe a window of 10 hours or so. If we have worked well, it's 10 hours gap between when we're done and when we're supposed to be letting people in. But this is how it actually starts. This is just piles of material and months of preparation. So when we get to this stage, basically we have, I don't have the number, but we have a few hundred scouts coming in, building all the tables. That's basically one of the first parts. On the actual building, the preparations start like I said, usually 6 months before. This event, we start planning the next. We are having a meeting about what's to prepare for next time and what we should think about. But we get in all the scouts building the tables, and once that's done, we start building up all the network and the power making sure there are spaces for all the exhibitors, and making sure everything works. And from day one, when we open the door, a lot of teams are already in place, like the teams that you as paying customers come here don't see, the ones that take care of the crew. And I'm going to talk about that a bit later. So Dreamhack, the actual event, is only a few days, and that's actually just the tip of the iceberg. It's only for a few days, and it's a lot of things, and it's a lot of sparks and shows and fireworks, but actually a lot more going on. So we're actually building we're building for about a week, if not more, making all the preparations, making sure the tables are there, because it takes a lot of time to get everything right. But Dreamhack itself is built all the year around, including the preparations. And we have actually we have Dreamhack HQ, which is responsible for recruiting all the artists or all the shows on stage, all the players who go here to be playing in the big tournaments, getting the commentators and stuff like that. So here's a YouTube clip from the start of the event. I'm not sure you've seen it, so what's happened? The sound doesn't really matter, but this is just a short video of how it's built. So if you didn't see that before, I just wanted to show you to it now. Show it to you, yeah. There's a lot of stuff. Is it echoing again? It's okay? Yeah, okay. It's a lot of preparations going on, getting like E-Type getting here, or a lot of other cool stuff that we want to bring up on the main stage. And that is Dreamhack HQ's work, to make sure that they are invited and all the preparations are made for them to come here. We have a team called the main stage, and they are responsible for building the main stage, and that's a lot of work, because they need to there's a lot of expensive and heavy equipment that needs to be checked and put in place for that work. It's not just putting a few wooden pallets together and putting a nerd on it. It's actually a lot of advanced work behind that. There's also inviting all the players, like esports personalities and stuff like that, since Dreamhack is trying to be a real big part in the esports world. So we need to be able to show off all the players and the commentators as well, to make sure that we get the attention from the esports world that we want, and grow in that aspect. But I am here to talk about crew, and this picture was taken in this event for, I think this event at least, for the big, no, it wasn't this event. Anyhow, it's a picture from our grand meeting, and we have it just the evening before we open, and we get all the information out to everyone, so everyone is on the same page and everyone knows what's going on. As I said before we're about 450 crew, and that's quite a lot of people that needs to be organized. So we have at the top we have the HQ, and below that we have the Dreamhack General, Event General, and that's Marcus Lindmark, that you've probably heard about him. And if you haven't, don't worry, he hasn't heard about you. But below that we have all the teams and their team leaders, and I'm one of those. I'm for information, together with another team leader. And we have at least one team leader for every team, and they are like responsible for recruiting for the team and to make sure that everything is organized beforehand, all the preparations made, and so on. And then they pick out a few people that called GAs or group admins that are responsible for the floor work, basically, making sure that everyone is on time for their shifts, maybe, or answering a little bit more advanced questions, or taking the bigger problems if there are any, since the TAs can't be awake all the time. So we need at least a few to be awake all the time, since Dreamhack is going on 24/7 for a few days. So everyone needs to be alert and not high on energy drinks. So that's a big part of being crew, to like take care of yourself, and we have a lot of stuff to help us with that. But here are a few of the teams. I didn't take the most advanced ones because I thought that ICE would mention some of them. But here are construction, and they are basically building the event or the more advanced parts of it. We're building the stalls for crew, making sure that everything is in order, helping out, helping the scouts with putting up all the switches and making sure the tables are correct, putting up trash bags and all the notes on the table so everyone knows where they're supposed to sit. We have coverage. They make sure that everything is remembered after the event is gone. Taking pictures, writing news articles, stuff like that. They did the awesome video we just saw. We have Dreamarena. This is one part of the Dreamarena. This is Dreamarena Orange. They have Extreme, and there are a few as well. They take care of the tournaments, making sure, well, not the tournaments, but they take care of the finals, making sure it's streamed properly, and so on. Then there's the main stage. I talked a little bit about that before. They make sure that the technology on stage is working, and I think they have responsibility over the lounge for the art for the people playing on stage. Then we have game crew. They take care of all the tournaments, making sure that people get registered and get the prizes and things like that. And then we have info. My team, we give out information to all, to basically everyone, even crew in some respect. We have a booth down in lobby south where we answer all and any questions, and if we can't answer, we know who can. Then we have support, help people repair their broken computers, and basically all in all when it comes to technical problems that we in information can't answer. And then we have medics. We always have alert and wake medic crew that can burst out into burst to any part of the event to make sure that if something happens, they have a close contact to both security and that's weird. Why don't have a they have a close contact to both security, which is another team I forgot to put here, and to medics or the hospital in town. There's another one that I forgot to add here that is security, and it's our biggest team. It's basically one 1/4 of everyone in crew, and they take care of basically all security measures. They guard the doors or make sure that, well, they try to make sure that nothing gets stolen, but can't be everywhere at once. So these are the three I was going to talk about that is concentrated on crew that you guys never see. We have the kitchen crew. They make sure we get fed, that we eat enough. They are open 24/7, 3 warm meals a day, or 3, but always manned and always ready to feed us with whatever they have available. And then we have relax and massage. They have like a little haven where we can go and just snuggle into a big blanket and maybe watch a movie or get a massage. It's really awesome after a long day standing or on the move. You can always go there and relax. Here are a few pictures from both food and relax area. On Dreamhack, we use a lot of resources. Since we are 450 crew, you can see that was just the first batch of food they bought when they came here and then like maybe a fourth of all the crew had arrived and they needed to buy food for them. So they went to Willys, which is a supermarket near here, and they tried to buy food, but they got stopped because you couldn't pay with cash when it was over 10,000. So they were stopped at the counter. But most people here in crew comes back every event because of like the atmosphere, the feeling of being part of this great event and all the people you get to know every time you're here. It's really amazing to feel a part of this big group and being included in this happening and feeling that you contributed to it. But when we don't have events, that's most of the year, we usually use something called Crew Corner, and that's like a more advanced forum or community where we meet up, chat about happenings, making plans, but also just sharing funny YouTube clips or telling funny jokes, selling stuff, making sure we meet up out of when it's not events, doing fun things together, and things like that. So I'm going to talk a little bit about me. As you can see, my name is Toste, but my nick is Toast. So I have a little logo that a friend made for me. I'm really happy about it. And I just wanted to tell me my experiences or my travel through Dreamhack. I actually came here let's see here, maybe it was 2004, something like that, was my first event here, but I came as an exhibitor. So I had a little booth down in D Hall where we made pins and invited people to play Dance Dance Revolution with us. But after that, I was invited to crew actually by a friend, and sure I could try it out. It seemed like okay. Since my employer then wasn't going to that event, so I thought I might as well go as crew then. And I got stuck, so I have been to every event since except 2, which I missed because I couldn't afford the travel ticket from Australia. So since then I've worked my way up, so to speak, but I've always felt welcome, and that was why I came back, because I only had a few friends when I got here, and when you get here the first time it's a bit nervous and you don't really know what to do, and you you listen real hard to everyone else. But then you start getting the hang of it, and you, like every event you're here, you get to know so much more people, and people start to know you, and it's becomes like you become part of this great family, and it's really rewarding to feel that, and come here, and just when you enter the doors, all the problems of the normal world is left behind, and you can focus, put your almost entire focus on the event and just relaxing or doing your best. Well, and doing your best. So all this together is what we in Crew do in like a grand scheme, but there's a lot more that we do, and there are a lot more teams and information like that. So if you would like to read about it or are interested in being Crew, you can go to crew.dreamhack.se and create an account, and you can read about the different teams. They always have a description. And a few months before every event, we open the possibility to apply. So that's basically what I had to say. I'm open for questions. Do we have anyone? Question over there.
Do you use English as the main communications language, or do you have to know Swedish?
Sorry, what? I didn't get that.
Do you use English as the main communications language in the Crew, or do you have to know Swedish to be in the Crew?
No, you don't need to know Swedish to be in Crew. A lot of the teams work like behind the scenes, and you don't really need to know Swedish there. And Sweden is a very open country, so or we're always educated in English. So basically, you can always get around with English. That's enough, absolutely. Even if you're in the information team that I work with, I wouldn't turn someone down just because they didn't speak Swedish.
Okay, thank you.
Got a question over here? Yeah. Yeah. Just get the mic so we get the question on the stream.
Yeah, there's a lot of people, like 450 in the Crew, for me, things like these are so awesome to build, and I always tend to forget myself and go entirely forget to eat and such. And does the kitchen also help you with paying attention to that? Just a little detail, but.
Well, yeah, of course they do. Basically you always have like the GAs or the like the group admins that I talked about earlier, or the team leaders, and they are always taking care of their crew, making sure that they are rested and eaten, and they drink well. And because in the kitchen we have a lot of many different drinks, and we have vitamins and many different foods, and we can cover all allergies and stuff like that. So you don't have to get worried about stuff like that.
Okay, so you keep your sanity.
Yeah, exactly. You keep your sanity. Absolutely. Any other questions? No?
Thank you.
Yeah, okay. Well, for the next speaker.
Hi, I'm Robin Larsson, and I work with Carl in the network team. And I work in the sub-team called Services. The Services team, like Carl said, works with the servers, all the services that we need to build the network. And I'm going to talk to you today about Anycast and Anycast DNS, and some about automated deployments. I will first go into Anycast DNS. So, what is Anycast? Anycast is a technology used to send traffic to the nearest location. So, if you see this picture, normally if I send out a request for a package, I get the answer from one location. But with Anycast, I send out a request and I get the answer from the nearest location. And I will go into some technical details now, and if you have any questions during the time, you can stop me and take them directly, or you can choose to after the presentation. So, for example, Anycast, it's a to use Anycast, you use a lot of different technologies. But here at Dreamhack, for example, we use them for our DNS servers. And I'm going to try to explain the technology for you. So, for example, if you have one client here and another client here, both of those clients going to make requests to this Anycast IP. For example, in this example, I'm going to use 9.9.9.9 as the Anycast IP. This server has a link net to this router and talks to the router with a routing protocol of your choice. The routing protocol will then announce this Anycast IP out into the routing table, and it will be distributed into the routers. The routers will then know the closest location to find this Anycast IP. So, for example, if this client A, makes a request to this Anycast IP, the traffic will go to this router, and then up to this router, and then to the server. Is there any questions about the technology of Anycast? Yes, please. The router uses a routing protocol. There's many flavors of those, but in Dreamhack here, we use BGP. Any more questions regarding the technology? Good. And we'll go on. How it works? Like I said before, the server uses a routing daemon to talks to the closest router. The routing daemon then announces the Anycast IP and push it down, and then the router distributes it to all the other routers in the network. Then we have a services-aware daemon running on the server, and this daemon can make decisions like, if my services is offline, I will then pull away my route from the routing table. So I will not anymore announce that my Anycast IP you can find in my link network. This way, if the service goes down, the server will remove the route to this router. The request will it will then be distributed to all the other routes, and it will be removed. So, for example, if the service goes down here, this server will send will remove the routes from the routing table to this router, and it will then be distributed to all the other routers. And when this client make a request or the Anycast IP. This router will send the user to this server instead. And that's how Anycast works. Why it is awesome? It is awesome because you combine different technologies and you get always get the answer from the nearest location. You get high availability. That means that you get, if one server goes down, if you have done it correct, the other one will take the traffic. And you spread the load of the servers. So the server with the nearest clients will get the load for that clients. So how do we use it here at Dreamhack? We use it distributing the DNS servers. So we have Anycast DNS servers. We have 2 servers. Those servers use Quagga. Quagga is a routing daemon. Quagga then speaks BGP with each router. Then on the server, we use EP forwarding. So we have a loopback interface where we have the Anycast IP, and then we use IP tables to forward the request to the Anycast loopback IP. Then we have a daemon written in Ruby that checks that the local DNS server we use as bind can resolve DNS requests. And if it can't resolve the DNS request, it will remove itself from the routing table, making the request go to the other server. Are there any questions regarding this? Yes, Size? We're using IP tables and IP forwarding for the Anycast IP is on a loopback interface on the server. So the server needs to forward the request from the link network to its loopback interface. And then we use IP tables to make the server send the package from the link address to the loopback interface and backwards. Yes? Yes, it's working for IPv6 as well. So we're using Anycast DNS servers for IPv4 and IPv6. Yes, guys? You can. It's a really good question. I should put it in here. Why it kicks ass? It kicks ass because in Windows, for example, you can distribute. You can have a list of DNS servers like number 1, number 2, number 3, and it will. If you can't get an answer from number 1, it will go to number 2 in the list. The problem with this is that it has to try with number 1, and it has a timeout with number 1 until it gets to number 2. So the problem is that if I send out a package to number 1, and number 1 is down, the request has a timed out before I try number 2. But as I described here, if number 1 goes down here, the routers will just send the traffic to the other one, to the other server. So the nice thing here is that you don't have you don't need to time out the request, even though the servers go down. And that's what I meant with high availability. Yes?
Did I understand correctly that the Ruby daemon, it actually tries to resolve a host name? It doesn't just check if the bind daemon is running?
The Ruby daemon, it does quite a couple of things. It has a list of different DNS names that it tries to resolve locally, and then it has a value. If it has failed to resolve all those 5 addresses, then it will. If it has failed 5 times and 5 different addresses, it will remove the route. So it tries to do a DNS query locally on the server to 5 different addresses, and if all 5 of those fails, it will remove itself from the routing table. So it doesn't check, it doesn't even check that the service is running, the process is running. It does a real query.
Do you have a monitoring system to check if other services are running?
You mean on the...
Just generally speaking, on all the servers.
Yes, we have some, use as an NPC to check some servers.
So, sorry, could you repeat that?
We use as an NPC to see if the service is running.
But the monitoring system?
I'm going to talk about automated management and deployments after this, after any cost. Any more questions? Okay, then I will move forward. I can show you how it works in our network. Here we have Anycast server 1 and 2. It is directly connected to our ASR routers, the ones that ICE was showing pictures of in the POP. And then you can see it then has redundant connections to the switches and then to the access switch and to the client. So if this client goes to this server and this server goes down, it will go, the router will send the traffic to this one instead. Dry software deployment. Dry is don't repeat yourself. So what I mean with that is how you can use software to automate deployments of other software so you save time. There's a couple of different open source tools available for doing this. You have a list there. But in general, I think the tool should reduce your time, not make it take more time. A lot of these tools take a lot of time to set up. So we always have to think, am I gaining time, or my setup so complex? It takes more time to set up and manage compared to how much time it takes to set up and manage manually. So here at Dreamhack, we use Chef. The reason for that we're using Chef is that Chef has 2 versions, one Chef server client version and one Chef Solo version. Chef Solo you can run locally on a machine, which means that when we get our servers, we can install our OS, and then we can use Chef Solo directly on that server instead of having to manage a server software as well. So the reason for using Chef Solo is that we can run it directly locally on the server. What Chef Solo does, it describes services. So it describes the DNS server, and it describes how I'm able to configure the DNS servers. So at the service team, in every event, we reinstall everything. We do this because of security. So when you get a server, we put the operating system on it, and then we use Chef to install all the different components and softwares. This means that we don't have to, every event, repeat the things that we did for last event. So we can take the configuration, just change some of it in global variables, and then we can install it again the next event. This saves us a lot of time. Chef Solo uses cookbooks. It has one cookbook for every services. It has a JSON object that describes every server. So if I say that I want to install a DNS server, I have a JSON attribute describing that this server is a DNS. It should install this daemon. It should be able to do queries from these sources, etc., etc. It uses a template system for managing configuration files. So in this template system, it takes variable from attribute files. Attribute files are variables you can set globally, and then you can overwrite them in the specific JSON attributes. For example, if I have like a DNS server, I can use global variables to set, like, for example, the Dreamhack network's IPv4 scope, and then I only have to set it once, but the host name I have to set in every JSON attribute for that specific server. So we have to, then we minimize the time that we have to take to change settings in the servers. And that's how we deploy software and manage our servers. Any questions regarding software deployments? Yes?
So the PXE boot server only installs a very basic operating system, and then Chef does the rest of the installation, is that correct?
Exactly, and exactly. Are there any more questions? Okay, thank you.